Far from any shore, a world exists, seemingly independent of our own. A colossal offshore drilling rig, a testament to human engineering, stands alone against the endless ocean, its silhouette stark against the horizon. It's a beacon of industry in a realm of nature. Waves crash relentlessly against its steel legs, a constant reminder of the ocean's power, anchored deep into the seabed, a precarious dance between stability and the untamed elements. Above, the air hums with the constant thrum of machinery, a symphony of industry, and the salty spray of the sea coats every surface, a constant reminder of the marine environment. This is a city on stilts, a self-contained ecosystem of human endeavor. Here, a skilled crew works in relative isolation, a community forged by shared purpose and the challenges of their environment, governed by the relentless rhythm of their tasks and the demands of the deep. Every action, from routine maintenance to complex drilling operations, is precise, meticulously planned, and executed with unwavering focus. The crew's mission, a vital undertaking far from the comforts of land, to drill deep beneath the ocean floor, venturing into the Earth's hidden reservoirs for the oil and gas that power our world, fueling our industries and lighting our homes. The drill string, a technological marvel, can extend miles below the seabed, a slender thread connecting the surface to the planet's depths. Reaching into ancient, high-pressure geological formations, where time and pressure have transformed organic matter into the energy source we seek. Helicopters, the lifeline of this isolated world, bring people, essential equipment and vital supplies, connecting this remote outpost, a solitary platform in a vast ocean, to the mainland and the world beyond. Here, the line between routine and crisis is razor-thin, demanding constant vigilance and preparedness. The forces at play are immense, the power of the ocean a constant threat, and the environment is unforgiving, demanding respect and caution at every turn. Humanity pushes the boundaries of exploration, venturing into challenging environments to secure vital resources, but the risks are ever present, a constant reminder of the power of nature. Control is everything, the key to safety and success in this demanding environment. One slip, a moment of inattention, and the consequences can be catastrophic, a stark reminder of the stakes involved in this high-pressure world. Offshore drilling represents a monumental challenge, a constant battle against the forces of nature. It's a high-stakes endeavor where the primary adversary is pressure, specifically managing the immense force that lies trapped beneath the seabed. This unseen power, if not carefully controlled, can unleash catastrophic consequences. Oil and gas reservoirs deep within the earth are akin to shaken soda bottles, brimming with volatile energy. They exist under immense pressure, a force that's been building for millennia. This pressure is what drives the oil and gas to the surface, but it also presents a significant hazard. The drilling crew, highly skilled and meticulously trained, must carefully pierce these reservoirs with the utmost precision and caution to avoid triggering an uncontrolled eruption, a blowout that could have devastating effects. The key to safe and efficient drilling is balance, ensuring that the pressure exerted from above within the well bore precisely matches the pressure exerted from below by the reservoir. This equilibrium is the foundation of well control. Drilling mud, a dense, carefully engineered fluid, plays a crucial role in this balancing act. It is continuously pumped down the drill pipe, circulating throughout the well. This creates a vital counterforce, a hydrostatic pressure that opposes the reservoir's natural tendency to release its contents. The weight of this specialized mud is what keeps the well stable and prevents unwanted influxes of formation fluids. It is constantly holding back the powerful upward push of oil, gas, and formation water, preventing them from reaching the surface in an uncontrolled manner. However, the geology beneath the surface is rarely predictable. It's a complex and ever-changing puzzle. As the drill bit penetrates deeper, each rock layer presents new and unique pressure challenges, demanding constant vigilance and adaptation. The sophisticated equipment used in offshore drilling must perform flawlessly without exception, because any equipment malfunction, no matter how small, can quickly tip the delicate balance and lead to a dangerous situation. Highly trained drilling engineers are constantly monitoring a vast array of sensors and gauges, scrutinizing every parameter of the drilling operation. They are prepared to make constant, minute adjustments to the drilling process, responding to the ever-changing conditions downhole. Ultimately, the safety of the drilling crew, the integrity of the offshore platform, and the protection of the surrounding ocean environment depends entirely on maintaining this delicate equilibrium, this precarious balance of forces. If the downward pressure exerted by the drilling mud falters, even for a moment, the risk of a catastrophic event rises exponentially, and danger rises fast. Offshore drilling, therefore, is a high-stakes act of control, a constant negotiation with the Earth's immense power, and it's a balance that must never be lost, a responsibility that demands unwavering focus and expertise. A kick is the first warning that control over the well is slipping. It happens when underground pressure overpowers the drilling mud, forcing fluids up the well bore. Imagine holding a beach ball underwater. If you lose grip, it surges upward. On a rig, a kick is detected by subtle changes, more mud flowing out, a drop in pump pressure, or a sudden gain in mud pit volume. These are the first signs that the well is fighting back. The crew is trained to spot and respond to these signals instantly. A kick demands immediate action to restore balance. If contained, drilling continues safely. If not, the situation can escalate rapidly. The well's warning must not be ignored. Every second counts in regaining control. Failure to act turns a warning into a disaster. When a kick starts deep within the earth, far below the ocean floor, an invisible threat begins to ascend. It's a moment that every drilling crew dreads, a breach in the carefully maintained balance of pressure and fluids. A race against time begins, a desperate scramble to regain control before the situation spirals out of control. Every second counts, every decision matters. The crew knows that the next few minutes could determine the fate of the well, the rig, and even their own lives. Lighter gas or oil, now an unwelcome intruder, rises up the wellbore with relentless force, expanding rapidly as it encounters zones of lower pressure. This expansion amplifies the kick, turning a small problem into a potentially catastrophic event. A small gas pocket, seemingly insignificant when trapped deep below in the Earth's embrace, can quickly transform into a massive, highly dangerous bubble as it nears the surface, posing an immediate threat to the integrity of the well and the safety of the rig. The crew, focused on their tasks, can't directly see this invisible ascent, this growing menace lurking beneath their feet. But their instruments, the vigilant sentinels of the well, show rising alarms, a chorus of warnings that something is terribly wrong. Mud flow surges unexpectedly, a sign that the well is no longer behaving as it should. Pressure spikes erratically, exceeding safe operating limits and pushing the equipment to its breaking point. The blowout preventer, or BOP, a complex and powerful piece of machinery, is the last line of defense against a full-scale disaster. A stack of high-pressure valves strategically positioned on the seabed, ready to be deployed at a moment's notice. When a kick is definitively detected, triggering the emergency protocols, the crew, acting with practiced precision, activates the BOP, initiating a sequence that slams shut powerful rams designed to seal the wellbore and prevent the uncontrolled release of hydrocarbons. If the BOP functions as intended, successfully sealing the well, the crisis is averted and the well is contained. Then, and only then, can the crew begin the process to kill the well by carefully pumping heavier mud down the wellbore, increasing the hydrostatic pressure and forcing the invading gas or oil back into the formation. This is an inherently tense and hazardous process, demanding unwavering focus and precise execution, but it ultimately restores control over the well, bringing a sense of relief and stability. However, if the BOP fails to activate, malfunctions during operation, or if the pressure from the kick is simply too great for the equipment to handle, the relentless gas bubble continues its upward journey, driven by buoyancy and ever-increasing pressure. The path to the surface, the route to potential disaster, remains frighteningly open and unobstructed. The danger escalates exponentially with every foot the bubble climbs, bringing the threat of a blowout closer and closer to reality. The crew's fate, the safety of the rig, and the potential for environmental catastrophe all hang precariously on the BOP's performance and the decisions made in these critical moments. The next moments, filled with tension and uncertainty, will decide everything, determining whether the well is brought under control or unleashes its destructive power. If all defenses fail, a blowout erupts, an uncontrolled release of oil and gas. The gas bubble bursts onto the rig floor, ejecting drilling mud and igniting a firestorm. Chaos engulfs the platform, deafening noise, toxic fumes and flames block escape. The blowout's force destroys equipment and threatens the rig's structure. Crew members fight for survival, trapped between fire and the open sea. A blowout is nature unleashed, a disaster that technology strives to prevent. The well becomes a wild volcano, spewing hydrocarbons until the pressure drops or intervention succeeds. The immediate catastrophe is only the beginning. The Deepwater Horizon disaster in 2010 revealed the true stakes of offshore drilling. During final well sealing, a methane kick bypassed safety barriers and the blowout preventer. Gas erupted, igniting explosions and fire that killed 11 crew and injured many more. The rig burned for 2 days before sinking, leaving the wellhead gushing oil. For 87 days, millions of barrels spilled into the Gulf of Mexico. Failed attempts to cap the well played out on the world stage. The disaster exposed critical failures in safety systems and procedures. It forced a global reckoning on offshore drilling safety. Deepwater Horizon remains a stark warning of what's at risk. A blowout's aftermath devastates more than just the rig. Oil spreads across the ocean, killing wildlife and poisoning ecosystems for decades. Fisheries and tourism collapse, and cleanup costs soar into the billions. The industry relies on layers of safety, advanced sensors, improved mud, rigorous training, and the blowout preventer. But technology is only as strong as the people using it. A culture of safety, where every worker is vigilant and empowered, is the ultimate defense. Offshore drilling demands constant respect for the forces at play. The quest for energy must never come at the cost of complacency. The deep Earth's pressure is silent, immense, and unforgiving. Only unwavering attention can keep disaster at bay.